National Building Code of Canada, NBCC 2015 Section 3.3.2.1 requires that penetrations through fire resistance rated assemblies maintain the fire resistance rating of the assembly. International Building Code, IC 2021 Section 717.5 requires that penetrations through fire resistance rated assemblies maintain the fire resistance rating of the assembly. National Fire Protection Association, NFPA 70, National Electrical Code, NEC, Section 300.22c requires that raceways passing through walls, floors, or ceilings be sealed with an approved fire stop system. FMC Flexible Metallic Conduit is not specifically listed as an approved fire stop material in the reference building or fire codes. However, it may be possible to use FMC in this application under certain conditions. Firstly, use a fire-rated collar or sleeve. Install a fire-rated collar or sleeve around the FMC where it penetrates the floor to maintain the fire resistance rating of the assembly. Secondly, seal with approved fire stop materials. Use approved fire stop materials to seal the penetration around the FMC, such as caulk, putty, or intumescent strips. Here is a recommended procedure. 1. Determine the fire resistance rating of the floor. 2. Consult with the local building inspector or fire authority to confirm the acceptability of using FMC and any additional requirements. 3. Install a fire-rated collar or sleeve around the FMC penetration. 4. Seal the penetration around the FMC with approved fire stop materials. 5. Inspect the fire stopping periodically to ensure it remains intact and effective. Always follow manufacturer's instructions for proper installation of fire stopping materials. To expand on the fire resistance rating requirements, it's important to understand that building codes mandate the integrity of fire-rated assemblies. When a penetration is made, it weakens the fire-resistant barrier, and the goal is to restore that barrier to its original rating. This is typically expressed in IRs, such as a 1-IR or 2-IR fire resistance rating indicating how long the assembly can withstand a standardized fire test. The choice of fire stop system must be appropriate for the fire resistance rating of the floor. Regarding the use of FMC, while it isn't inherently a fire stopping material, it can be incorporated into a compliance system. The fire-rated collar or sleeve plays a crucial role by providing a physical barrier that prevents the spread of fire and smoke through the penetration. These collars are designed to expand when exposed to heat, effectively sealing off the opening. The approved fire stop materials, such as caulk, putty, or intumescent strips, further enhance the fire protection. Fire stop caulk is a specialized sealant that resists heat and flames, preventing the passage of fire and smoke. Firestop putty is a moldable material that can be packed into gaps and around conduits to create a fire-resistant seal. Intumescent strips expand when exposed to heat, filling voids and creating a tight seal that restricts the spread of fire. When selecting firestop materials, it's essential to choose products that are specifically tested and listed for use with FMC and the type of floor construction. The manufacturer's instructions will provide detailed guidance on the proper installation techniques, including the required depth of the sealant or putty and the correct placement of the collar or sleeve. Consulting with local building inspectors or fire authorities is a critical step in the process. It can provide valuable insights into local code requirements and interpretations. They may also have specific guidelines or approved product lists that can help ensure compliance. The inspection of fire stopping is an ongoing responsibility. Over time, fire stop materials can degrade due to environmental factors or physical damage. Regular inspection should be conducted to identify any signs of deterioration such as cracking, crumbling, or displacement. Any deficiencies should be promptly repaired to maintain the effectiveness of the fire stop system. In addition to the code requirements, it's also important to consider the practical aspects of the installation. The size of the penetration should be kept to a minimum to reduce the amount of fire-stopping material required. The FMC should be properly supported to prevent it from sagging or moving, which could compromise the fire stop seal. The work area should be clean and free of debris to ensure proper adhesion of the fire stop materials. The installation should be performed by qualified personnel who are familiar with the code requirements and the proper installation techniques. They should have the necessary tools and equipment to perform the work safely and effectively. It is also essential to document the installation, including the date, location, materials used, and the name of the installer. This documentation can be helpful for future inspections and maintenance. In summary, penetrating a fire-rated floor with FMC requires careful planning and execution to ensure compliance with building and fire codes. By understanding the code requirements, selecting appropriate firestop materials, following manufacturer's instructions, consulting with local authorities, and performing regular inspections, it is possible to create a safe and compliant installation. Remember to always prioritize safety and consult with qualified professionals when dealing with fire-rated assemblies. When working within a hospital environment, there are additional considerations to keep in mind. Firstly, infection control is paramount. Penetration work can generate dust and debris, which can harbor harmful pathogens. It's crucial to implement strict dust control measures such as using HEPA filter vacuums, creating containment barriers, and disinfecting surfaces regularly. Secondly, noise control is also important. Hospitals are sensitive environments, and excessive noise can disrupt patient care. Use quiet tools and equipment, and schedule work during off-peak hours when possible. Thirdly, disruption to services should be minimized. Hospitals rely on a complex network of utilities and systems to function properly. Coordinate the work with hospital staff to avoid disrupting critical services such as power, water, or medical gases. Also, consider the potential for electromagnetic interference. Medical equipment can be sensitive to electromagnetic fields, so take precautions to minimize interference from electrical work. Use shielded cables and conduits, and maintain appropriate separation distances between electrical and medical equipment. Ensure that all work complies with hospital safety regulations. Hospitals have strict safety protocols in place to protect patients, staff, and visitors. Familiarize yourself with these protocols and follow them diligently. For example, you may need to obtain special permits or undergo safety training before starting work. Always wear appropriate personal protective equipment, such as gloves, masks, and eye protection, and dispose of waste materials properly to prevent contamination. Before starting any work, conduct a thorough risk assessment to identify potential hazards and implement appropriate control measures. This assessment should consider factors such as the presence of hazardous materials, the potential for falls, and the risk of electrical shock. By addressing these additional considerations, you can minimize the risks associated with penetration work in a hospital environment and ensure the safety of patients, staff, and visitors. Remember to always prioritize safety and consult with qualified professionals when dealing with hospital infrastructure. Furthermore, let's talk about the specifics of selecting the correct fire-stopping material. Several factors influence the decision. The type of penetrating item, in this case FMC, the substrate material A. Concrete, the size and shape of the opening, the fire resistance rating needed, and any movement expected between the penetrating item and the substrate are all important considerations. Fire-stopping materials are broadly categorized into several types. Firstly, sealants. These are typically used for small openings and gaps. They are flexible and can accommodate some movement. Secondly, putties. These are moldable and often used for packing around penetrations, providing a tight seal. Thirdly, foams. These expand to fill irregular shapes and voids and are often used for larger openings. Fourthly, wraps. These are used to protect combustible penetrations like plastic pipes. Fifthly, collars. These are installed around pipes or conduits and expand when exposed to heat, sealing the penetration. And sixthly, composite systems. These combine different materials to achieve the required fire resistance rating. When choosing a fire-stopping material, it is essential to verify that it is tested and listed by a recognized testing laboratory such as Underwriters Laboratories, or Intertech. These listings ensure that the material has been evaluated for its fire resistance properties and that it meets the requirements of the applicable building codes. The listing will specify the types of penetrations and substrates for which the material is approved, as well as the required installation methods. Installation is also critical. Proper surface preparation is essential for achieving a good bond between the fire-stopping material and the substrate. This typically involves cleaning the surface to remove any dirt, dust, oil, or other contaminants. Fire-stopping material should be installed in accordance with the manufacturer's instructions. This will specify the required depth of the material, the proper mixing ratios, and any special installation techniques. The installation should be inspected to ensure that it is complete and that there are no gaps or voids. Regular inspections should be conducted to ensure that the fire-stopping material remains intact and effective. If any damage or deterioration is observed, the material should be repaired or replaced immediately. It is also important to document the installation, including the date, location, materials used, and the name of the installer. This documentation can be helpful for future inspections and maintenance. The NEC provides specific requirements for fire stopping in Section 300.21. This section requires that electrical installations shall be made in a neat and workmanlike manner, and that any openings around electrical penetration shall be sealed to resist the spread of fire or products of combustion. The NEC also references other standards such as UL 1479, Standard for Fire Tests of Fire Stopping Systems, and UL 2043, Standard for Fire Tests for Heat and Visible Smoke Release for discrete products and their accessories installed in air handling spaces. These standards provide detailed requirements for the testing and listing of fire-stopping materials. In addition to the NEC, local building codes may also have specific requirements for fire stopping. It is important to consult with the local building official to determine the applicable requirements for a particular project. In summary, selecting and installing fire-stopping materials requires careful consideration of a number of factors. By understanding the different types of materials available, verifying that the materials are tested and listed, following proper installation procedures, and conducting regular inspections, it is possible to create a safe and compliant installation.